Hi everyone, Assalamualaikum. In this video, we will continue with partial derivative for implicit functions. Now we look at example 2 from previous semester papers. Use partial differentiation to find the equation of the tangent line to the curve x minus x squared bracket squared plus 2y set x minus 13y minus 4 equals to 0 at the point 4, 3. Alright, first step, we need to bring all terms to one side and write the function given as f. Okay. So now from here, we already have all terms in the left hand side, in one side only. Okay. So we can write f equals to x minus y squared bracket squared plus 2y set x minus 13y minus 4. Okay. Step 2, we need to find fx and its value at the given point. Okay. Fx means partial derivative of f with respect to x. We treat x as a variable and then we treat y as a constant. Okay. So from here, we can write x in different colors. Okay. And we can rewrite x at the back. Okay. Because we treat y as a variable. So, to avoid error and easy to differentiate, we can use different color for x. Okay. And then from f here, we can find fx. Okay. Alright, from x minus y squared bracket squared. Okay. To differentiate, we just imagine, let's say we have derivative of x minus 4 bracket squared with respect to x. Alright, from here, we imagine, let's say, our y equals to 2. Okay, because now we treat y as a constant. Let's say y is a constant 2, so 2 squared equals to 4. So we just imagine, let's say we want to differentiate x minus 4 bracket squared. So we can use generalized power rule. We move 2 here to the front. Okay, power to the front. So we get 2 here. And then we copy. So we have x minus 4. And then bracket to the power of 1 here because 2 minus 1. Okay. And after that, we multiply by the derivative in bracket here. So when we differentiate x, it equals to 1. And when we differentiate minus 4, so we get minus 0 here. Okay. So, same goes to when we differentiate x minus constant squared, bracket squared. So, we just move power to the front here. So, we have 2 here. And then we copy in bracket. Okay. And then times. We differentiate x with respect to x. So, we get 1. We differentiate constant y squared, so we get 0, right? And then, to differentiate 2y, x to the power of half, okay? We imagine, let's say we want to differentiate 4x to the power of half, okay? Let's say we replace y equals to constant 2, so 2 times 2 equals to 4, okay? And then when we differentiate 4x to the power of half, we already know the answer equals to half times 4 here equals to 2x and then to the power of negative half here. But before we get 2x to the power of negative half, actually we just keep the constant in front here. Then we differentiate x to the power of half using power rule. We move the power of half here to the front here, and then x, and then half minus 1. So we get negative half here. So we can simplify 4 and 2 here. So that's why we get 2x to the power of negative half. So when we differentiate 2y, which is constant, x to the power of half, so we just keep the constant in front, okay, like this. we just keep the constant 2y in front and then times, we differentiate x to the power of half. So we get half x to the power of negative half. Alright? And after that, to differentiate 13y, y we treat as a constant. So constant times 13 equals to constant. And when we differentiate any constant, the answer equals to 0. Alright? And then when we differentiate constant 4, it is equals to 0 here. Okay? Alright, after that, we can simplify. Okay? From here, we can simplify 2 and 2 here. Okay? So, after we simplify, so we get fx equals to 2 times 1 here equals to 2. And then x minus y squared. Okay? And then after we simplify 2 and 2 in denominator here, so we have y, okay, y, and then we can move x to the power of negative half, we move down, okay, using the properties of indices. When we move x to the power of negative half to denominator, so we get x to the power of positive half, which is equals to zx. Okay, and then minus 0, minus 0. Okay, no need to write. Okay. Alright, after we find fx, then we can find the value of fx at point 4, 3. Okay, so we replace x equals to 4. Okay, and we replace y equals to 3. Okay, y here we replace equals to 3 and x we replace equals to 4. Okay, then we simplify. So we get 2 times 4 minus 9 equals to negative 5. And then 3 over square root of 4 equals to 2. Okay, then we get fx equals to negative 17 over 2. Okay, now we done step 2. Okay, we done find fx and its value at the given point 4, 3. Okay. Alright, from the previous slide, we get fx equals to negative 17 over 2. Then we can continue with step 3. Find fy and its value at the given point. Okay. To find fy, we differentiate from f. Okay. F equals to x minus y squared bracket squared plus 2 third xy minus 13y minus 4. Okay. Alright, then we get fy here. Okay. Before that, fy is a partial derivative of f with respect to y. We treat y as a variable and at the same time, we treat x as a constant. Since we treat y as a variable, so to avoid error and easy to differentiate, we can write y in different colors. And we put variable y at the back. Okay. Alright, then to differentiate x minus y squared bracket squared. Okay. We just imagine, let's say we want to differentiate 2 minus y squared bracket squared. 2 here means x. Okay. We treat x as a constant. So let's say we replace x by constant 2. Then we have derivative of 2 minus y squared bracket squared. Okay. With respect to y. So from here, we can differentiate using generalized power rule. We move power to the front and then we copy the function in bracket. And then we get the power of 2 minus 1, which is 1. So no need to write. Then we multiply by, we differentiate the function inside bracket. So we differentiate constant 2, it equals to 0. And then we differentiate minus y squared, so we get minus 2y here. Okay. So same goes to this function. When we differentiate x minus y squared bracket squared, we move power to the front and then we copy the function inside bracket. And then we have to the power of 1 here because 2 minus 1. And then we multiply by, we differentiate the function inside bracket. We differentiate constant x. The answer equals to 0. And then minus, we differentiate variable y squared with respect to y. So the answer equals to minus 2y. So we can compare this. Okay. After that, we want to differentiate 2/3 x, y. Okay. X we treat as a constant. Let's say x equals to 2. Okay. So square root of 2. Let's say x equals to 4. So square root of 4 equals to 2. 2 times 2 equals to 4. Let's say we imagine we want to differentiate for y. Okay. The answer equals to 4. Okay. 4 means constant. So when we differentiate constant y with respect to y, the answer equals to constant. Okay. So same goes to this function. When we differentiate 2/3 x, y, 2/3 x is a constant. Okay. So the answer equals to constant. Okay. We compare from here. Okay. After that, we want to differentiate 13y. Okay. When we differentiate 13y with respect to y, the answer equals to negative 13 here. Okay. Then when we differentiate 4 means constant. With respect to y, the answer equals to 0. Alright. After that, we simplify. 2 times negative 2y equals to negative 4y. And then x minus y squared. And then plus 2/3 x minus 13. Okay. Alright, after we find fy, then we can find the value of fy at the given point for 3. Okay. So our fy equals to negative 4. Then we replace y by 3. And then x here equals to 4 minus y equals to 3 and then squared plus 2 square root of, we replace x by 4. Okay, and then minus 13. Alright. After that, we simplify. Here we get negative 4 times 3, we get negative 12. And then 4 minus 3 squared, 4 minus 9 equals to negative 5. And then square root of 4 equals to 2 times 2 equals to 4. And then minus 13. Okay. Then we can solve. So we get fy equals to 51. Okay. So now we done find fy and its value at the given point for 3. Right. Alright. Since the question is asking about the equation of tangent line, so we need to find gradient first. Gradient means dy over dx. Okay. And dy over dx equals to negative fx over fy. Okay. Alright. From here, fx, from the previous slide, we get negative 17 over 2. Okay. Fy equals to 51. Okay. Alright. Then we have negative here. Okay. So negative times negative equals to positive 17 over 102. Okay. This is our dy over dx. Alright. From the previous slide, we get dy over dx equals to 17 over 102. Then we can continue with step 5. Gradient equals to dy over dx at the given point. Okay. So our gradient m equals to dy over dx equals to 17 over 102, right? Then equation of tangent line is y equals to mx plus c, because equation of tangent line is a straight line. So that's why we use y equals to mx plus c, right? And then at the point 43, and m equals to 17 over 102. Now we want to find c here, okay? So we replace y equals to 3, okay? Here. And then we replace m equals to 17 over 102, right? We replace x equals to 4, okay? Then we solve for c, okay? So c equals to 7 over 3, right? After that, we substitute back into y equals to mx plus c. So the equation of tangent line is y equals to m equals to 17 over 102, and then x plus c equals to 7 over 3. So this is our equation of tangent line for this curve at the point 4, 3. Okay. Coming up next, more examples of partial derivative for implicit functions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.